Welcome to The Explainer. We're diving straight into a massive, fundamental shift happening literally right now in energy storage. We're talking about the rapid transition away from short-duration utility-scale battery systems and the hard pivot toward mandatory 4-hour and longer duration systems. If you're involved in grid infrastructure, project development, or system engineering, this shift changes absolutely everything about how we build and deploy energy storage on the grid.
Grid operators are steadily closing the book on short-duration 1 to 2 hour battery systems. That quote right there, it perfectly captures the burning platform our industry is standing on today. The era of the short-duration battery is officially over. But why is this happening so fast? And what does it actually mean if your current project pipelines are still relying on old standards? Well, that is exactly what we're going to unpack. So, here's our roadmap for today. 1. The short-duration sunset. 2. Rise of evening ramps. 3. The market lockout. 4. The engineering reality check. And 5. 3 strategic design approaches.
Let's jump into Section 1, the short duration sunset. Why the 1 to 2 hour BESS is fading.
For years, the 1 to 2 hour battery was the absolute gold standard, right? I mean, it was cheap to build, super easy to cool, and gave grid operators this perfectly compact short duration solution. It was the go-to asset for just clipping those momentary spikes in demand. But, as you're gonna see, today's grid operates very, very differently than the grid of even a few years ago.
We're dealing with a stark difference now. Legacy peak shaving versus modern solar shifting. We are moving away from basically taking a pair of scissors to a momentary peak and shifting entirely to long, continuous power delivery. It's all about capturing massive amounts of solar energy during the day and continuously discharging it over hours later on.
Which brings us to Section 2. Rise of evening ramps, the catalyst for 4-hour storage.
So what's driving this? The underlying problem is the deep, protracted evening net load ramp. These are protracted surges in grid demand that happen right as high-penetration renewable generation drops off. It's what we often call the neck of the duck curve. Basically, solar creates this massive drop-off in power generation just as evening demand skyrockets. Everyone gets home, the appliances go on, and the sun sets. Those legacy 1 to 2 hour peak shaving units, they just can't bridge a gap that lasts for hours. The grid literally needs sustained power to keep the lights on.
Let's move to Section 3, the market lockout, the cost of clinging to the past.
Here is the harsh reality. If developers cling to those compact, short-duration asset layouts, they are facing a complete market lockout. First, you get locked out of modern capacity markets entirely because grid codes are evolving to mandate 4-hour minimums across the board. Second, you miss out on those highly lucrative solar shifting windows we just talked about. And finally, those legacy layouts you've relied on for years, they're rendered completely obsolete.
Now for Section 4, the engineering reality check, doubling capacity in the same footprint.
The physical reality of doing this is incredibly complex. Doubling or even quadrupling energy capacity within your exact same project footprint is far more than a simple procurement adjustment. You can't just call up your supplier, ask for bigger batteries, and plug them into your old layout. Actually, scratch that. It's literally impossible. It requires a complete, ground-up redesign of your entire system architecture.
Let's break down the specific constraints of this new 4-hour rule. In terms of container space, you are suddenly dealing with significantly increased rack density. For thermal management, you have to handle prolonged continuous thermal stress. And for auxiliary power, you are managing prolonged loads that your legacy systems were just never built to handle.
But the single most dangerous factor here is thermal management. Prolonged continuous thermal stress is the primary threat to these new system architectures. Think about it. When you pack way more batteries into the exact same space and then run them twice as long, the heat saturation brings a very real risk of thermal runaway. You absolutely cannot compromise safety just to get more density. It's a non-negotiable.
Which takes us to our final section, Section 5, 3 strategic design approaches, how EPCs can actually survive this shift.
To successfully scale up that energy density while keeping everything safe, EPCs have to adopt 3 specific design approaches from the ground up. Step 1, completely redesign your thermal management systems to handle that prolonged continuous stress. Step 2, deeply optimize your container space and rack density to physically fit the new capacity. And Step 3, re-engineer those auxiliary power loads so they can actually sustain operations over a much longer duration.
So, I'm going to leave you with this one critical question.
Are your upcoming pipeline layouts fully adapted to the 4-hour standard, or are legacy 2-hour footprints still secretly dominating your engineering designs? Look, in an industry where grid codes can basically change overnight, clinging to the past isn't just bad engineering, it's market suicide. The 4-hour era is already here. The real question is, are you ready for it?